In the previous video, we have already identified our null and alternative hypothesis, and we have already determined using one subtest, the ftest2 sample for variances, that the t-test that we will use is t-test assuming unequal variances because this p-value is lower than our alpha. So now, we shall now go to our t-test. So, we will now go to our data analysis. This time, let's just look at it closely. We shall now go to t-test 2 samples assuming unequal variances. So with that, we will click OK. So now, here we have this one. Now, variable 1 range should be the same variable 1 that we have used in the last f-test that we did. And going back at the last f-test that we did, here, our variable 1 is actually city B because it has a bigger or a larger or higher variance. Therefore, our variable 1 should be city B, our variable 2 should be city A. So, going back here, we shall select variable 1 as city B and variable 2 as city A. There we go. We will leave, there we go. We will leave the hypothesized mean difference blank as we will not need it anymore. We saw that we had labels, so we will have labels. Our alpha is 0.05, so we will leave it like this. And our output range, we'll now put it here, beside. There we go. And if everything is set, we click OK. So now, let's just adjust this a little bit. Here you go. So now, here is our table. So here, you can see now that this is the table that will come out. We have the mean, the variance, and all that. Now, if you remember degrees of freedom, it's this one. So there are 19 values that can vary with our sample. So this is the degree of freedom that was used rather. Now, which one will we use? One tail or two tail? Going back to our alternative hypothesis, we have here that the alternative hypothesis is that mean A is not equal to mean B, not whether someone is greater than or someone is less than. Therefore, this is a two-tail test. Hence, we're going to use this one, which is the mean of two tails, 0.358081. So we'll round it off to 0.36. Now we can go to step 4. The p-value of 0.36, is it bigger or smaller than 0.05? Actually, 0.36 is bigger than 0.05. Therefore, we should not reject HO. Therefore, our conclusion should be there is no sufficient evidence to reject HO. Therefore, is there enough evidence to support the tax collector's claim that the means are different? Since there's no sufficient evidence to reject HO, we shall conclude with HO, which is the means are the same. So is there enough evidence to support that claim? There is not enough evidence because the claim is that they are not equal. So that is an example of how we conduct t-test of independent means.